Say hi to Harold. Morning, everybody. Hope everyone's doing well. Hello, Dimitri. Nostrovia. Hey, David. David, did you like that video of my ducklings? Not my ducklings, duckling in the creek. I tell you what, we were driving across our bridge, and we had to stop the car and get out of the car and spend a few minutes looking at those ducks and that little duckling. About the cutest thing I've seen in a long time. It's about this big, and its mommy and daddy were there, and it was just paddling away. And it had actually gotten away from its mom and dad. It was about 20 feet away from them, and I went downstream, and I'm thinking, do I need to try to help this thing out? And it saw me and got scared and started paddling back towards its mom and dad upstream, and it went at an astonishing speed. I mean, it just made me laugh. Cutest thing. I'm actually going to be posting a few videos from my YouTube channel on the face page of our Google classroom, just for your enjoyment. It's not any assignment that's due with it or anything. Just so you can enjoy it. One's probably going to be that little baby, and the other is some of the things we got going on in my little greenhouse, and some ideas, maybe some other things. But usually a lot of this stuff we do in the classroom, you guys get to see it, even if it's a different grade that's doing it. But so be it. Now, let's get going. Dimitri, I don't know if you were looking over your sister's shoulder when she was on, but we are going to be going through some things with the scientific method for our big project that I want you guys to do. And so let's talk about the steps of the scientific method. There are different versions. We use a 6-step scientific method. And so the first part of the scientific method is, if you know it, type it in to the live chat. What it actually is, we're trying to answer a question. And we do that by asking a question, okay? So the first scientific method is, I didn't wait for you guys to ask a question. Thank you, Dimitri. And I've already forgot who, oh, that's Lucas. So anyways, hey, Lucas. Anyways, the first thing we do in a scientific question is, scientific method is ask a question. If you think about all the sickness that's going around, people being sick, this COVID-19 that's out there, there's a lot of scientists that are asking a lot of questions. Everyone's trying to find a solution. There's probably, hi, Mr. Fosnight, there's probably more science going on right now dedicated to a cure and therapies and treatments for the coronavirus than I ever imagined in my lifetime for anything. People are, I mean, it's the center of our focus as a society, as a world right now, is to try to find solutions for this. What's actually happening is people are using the scientific method. They're asking a question. The next step is they're trying to figure out what they know. So if you know what we call this next step, type it into the box. We're trying to figure out what we know. And there's a couple ways to do that. You can recall information that you already have in your brain. Brains are absorption facilities, just like a sponge. Your brains are like sponges, okay? If you learn something, it's in there. Sometimes it's hard to get it back out. But you might have to figure out a way to get that information out of your brain. You might have the information. The expert in lab procedures is our own Mr. Fosnight, who spent years in the lab. You know, if I have a question about what do you think the best way to do this experiment is, guess who I'm going to ask? Yeah, I'm going to ask Mr. Fosnight, because he knows even better, much better than I do, what the right thing to do is in a situation. Okay, so I'll get back to what I was thinking. Once we ask a question, how do I solve a problem, or let's talk about a few ideas. You can do whatever you want. I'm just going to throw a few ideas out there. Think about maybe doing something that has to do with permeability or even saturation. Does anybody know what either of those words mean? So saturation or permeability. It's important to know because those are general science concepts that we all need to know. They keep coming up again and again. I apologize, my ankle itches really badly. An example of saturation would be to take a sponge, a new sponge, and put it in a bowl of water. And it's going to get to a point where, yeah, it's completely soaked with liquid. That's right. It's going to get to a point where it can't hold anymore. So this has actually taken a lot of water in it. As I pull it out, it's saturated. So it's going to drip, at least for a little bit, right? Until gravity stops acting upon it. And this still has a considerable amount of water in it. It's saturated right now. How do I know? Because I can squeeze a lot of water out of this, okay? But it'll only be able to hold so much. That's called something saturation point. So can I do some sort of an experiment that deals with saturation points? Kennedy, hey, that makes me smile, Kennedy. Glad to hear from you. Can we do an experiment that deals with saturation points? I just got water everywhere. Yeah, we could. Could it have something to do with how things we have around the house? One of the keys to this project is try to make it using things around the house. Could you do saturation point with foods? Yeah, you could. I talked about measuring how much water can be absorbed into different foods. For example, you know, if you guys don't have beakers and you don't have graduated cylinders at home, but you do have measuring cups. So you could use a measuring cup and put equal amounts of water in something, in a bowl or a cup, as long as you knew, like if it was 1 cup of water, whatever, excuse me, then you could test even. Like what could you test? I don't know. An ounce of pasta, an ounce of rice, an ounce of beans. That's just one idea. How much water will they absorb before they're saturated? How do I measure that? Well, remember, you put a certain amount of water in, you take the saturated food out and measure how much water is left. Do a little subtraction, and you know how much. That's an idea how much was actually saturated. Another idea would be permeability. Does anybody know what permeability means? It doesn't even have to be with food, by the way. You could do it with materials. You can do it with a Q-tip, cotton balls, pieces of clothing, anything that you can think of that would absorb moisture or absorb a liquid. You could do it with different foods, pieces of wood, plastics. Will plastic absorb water? Will a piece of wood absorb water? You could think of a lot of things. Does anybody know what permeability is? Permeability has to do with the amount, if any, of a liquid or gas that's allowed to pass through a material. Okay, so permeability can't usually of a gas or liquid. Yeah, that something can pass through it. Permeability, the amount of a gas or a liquid that can pass through. I'm going to say a substance. It sounds a little bit more scientific. All right. So what could we be measuring for permeability? Again, we could do it with food. Okay. Let's say you have, could you measure a grape or a raisin, an orange, pieces of fruit? Will they, how do you measure permeability? Well, if it has its skin on it, is water passing through it at all? How would you be able to do this? This would be a little bit tougher, but if you had something like a digital scale that you use for measuring food, this would be good to use because you can measure in grams and stuff. Don't go out and buy one. Do a different experiment. I don't want this to be a big expense for anybody. We're supposed to be staying at home whenever we can. Use what you got at home to make your experiment work. You got things around your house that you can make an experiment work. You can use a scale. You can do something that involves time, okay? How long will it take to do something? You might need a little kitchen timer or your stopwatch. Your phone has a stopwatch on it. Well, that's a really, really, really good question. How many questions should I have or answer? You should only have one main question. So if you're testing the best temperature to cook, the best temperature to make some sort of bread. Let's say we're making bread. Bread from scratch. We need flour, we need yeast, and we need water. And so the question would be it really would be one question. What is the best temperature to make bread? Okay. And so what is the best temperature for the yeast to make bread? So when you mix the yeast with water, you could use hot water, warm water, cold water. You're comparing three. You still only have one question, but maybe you have 3 or 4 experiments set up, right? And so your question is, what's the best temperature to get me the best result, the best tasting piece of bread, or that it rises the best, it rises the most appropriately. You don't want it to rise too much, right? Rises too much, It'll be super airy. You might have big pockets and big holes in your bread. If it doesn't rise at all, you know, you're eating flatbread, and it's like Goldilocks, right? You don't want it too hot, too cold, just right. And so, but your question really becomes what is the best temperature for preparing yeast to make bread or biscuits or rolls or whatever you're going to make. And that could, think about that, that could transfer over into anything. Something as crazy as doing a homemade iron-on. Is there a way to do a homemade iron-on shirt? You know, what's the best temperature to get wrinkles out of cotton? What's the best temperature to get wrinkles? I mean, you could think about a million things to do an experiment, but it really only becomes one question. But there are a lot of parts to that, but there ultimately is one question that you're trying to answer. And I hope that helps you guys focus on what your question is. And remember, you're going to be doing background research, which is ask a teacher, ask yourself, ask a parent, do research online to get the answer. And then you write your hypothesis in this way. You say, I believe that this is the best, this is the result I'm going to get. And I believe that because, okay? Now you're tying in your background research to your hypothesis. I believe this is going to happen, but why the heck do I believe that is going to happen? Because I've done it 50 times before? Ooh, that's not what an experiment's supposed to be about. You're supposed to be learning something new. Have I done something remotely similar or had a different experiment? That's okay. But you are supposed to be trying to learn something. So you're tying in your hypothesis to either your background knowledge or what you learned from an expert or what you think you learned online. And this is why. I think that sample B is going to have the best result because I think sample C is going to fail. I think sample A will be okay, but I think sample B is going to be the best result. That's what a hypothesis is supposed to be. Okay, let's move on past that. And you guys still have time to ask me questions online or here, or message me on Google Classroom. The next part of that is writing a materials list. So let's say we're doing something with foods or liquids or whatever. You guys don't have beakers at home. You don't have graduated cylinders at home. But you do have things like drinking water. You do have measuring cups. This has a specific amount of, this is actually 1.05 pints. This is basically a pint of water. We don't use Google Meets, Google Classroom. If you need to communicate with me, I haven't been using Google Meets, at least not yet. But you can message me, Kennedy, on Google Classroom. And we can, or I don't think any other teachers are using it either. I'm not sure. But you can message me anytime, email me. I think it might have even been either Dimitri or his sister that we were messaging or emailing back and forth at 10 o'clock at night. I'm not saying that I'll always be available at that time, but I do check it outside of regular school hours because I got, this is an unusual thing. All right, so a materials list literally is going to be, what do I need to do the experiment? I need a measuring cup. I need a ruler, okay? I need a pen, I need a paper, I need to, where did I do with it? I need to create some sort of a graph to record my data. I need a timer. I need a scale. I need to be able to measure something. I need a sponge. I need food. I need whatever food I'm using. I need materials, cloth. That's what your materials list is. Yeah. And so what you're going to find out is when you present me a materials list, Mr. Fossilite and I are going to look at it. We're going to say, yeah, that's pretty good. Yeah, I think you need to use this. Maybe you're missing something, maybe you're not. You're going to get that checked off. You're going to do this all on the Google Doc that's online, and each one has a subject. I have to scan this because I can't find it in my files and post it so you guys can and look and do each step. That's what that is. I posted that before. I showed you that before you even asked the question. It's called a project timeline. And I'm sorry, I can't stop itching my ankle. It's a project timeline and it's got all the steps. I have it in a file somewhere on one of my computers, either the school computer or my personal, and I can't seem to find it, but I've been looking for it. And if I can't find it today, I will have to scan it and make a new file. I'll get it up there as soon as I can for that. Real quickly, the next step is to write your procedures. If you saw Mr. Fossilite posted the peanut butter and jelly video, if you haven't watched it, watch it. Even if you watched it before, watch it again. I watched it 10 times. It still makes me laugh. It's a dad with his two kids, and they're giving him instructions on how to make a peanut butter and jelly sandwich. The point of that is writing procedures for a lab is the most difficult part of this, probably. You're going to write your procedures, and they're not going to be right the first time. I'm going to tell you right now that I'm going to say, you need to add this and this. If I do give you a set of instructions or if you do give me one that I think are really good, chances are when you go to do the experiment, you're going to go, I missed 2 steps. So what do? You go back to your procedures in a different color. You write your procedures in a different color. Let's say you did everything in black. Well, once you realize that you missed a procedure, you're going to go back and do it in red ink. So I know you realize that you had to add something, and so you added it. And that's awesome. That means you're learning something along the way. It doesn't mean you did something wrong. It means that you're learning something in the process. So if you do your experiment and you fail, understand that that's perfectly fine and perfectly acceptable. What do you do at that point? And that's down the road. We'll get to that. But what do you do at that point if you get the wrong answer? You go back up to ask a question. You go back up to not ask a question. You go back up to your hypothesis. What do I need to change to make it work? If none of your examples worked the way you expected, if say you had A, B, and C, and none of them came out, one variable, the V is for variable, change one variable to make that experiment work. We don't want to change multiple. We're running out of time. If does anybody have any questions, please ask them now. I expect to hear from you guys quite a bit during this phase for this experiment. I'm going to tell you right now, I don't want you to go, and many of you don't have access to go out or don't have extra cash with what's going on in the world. People have lost their jobs or whatever. Try to do something with something you have around the house that you can just enjoy. House, have it be family time. You can do something with a brother, a sister, aunt, uncle, parent, grandmother, grandfather, whatever, and make them part of the project, and you guys can enjoy each other doing the experiments. So I know you guys will have questions. There's usually a lot of questions. We do this in the classroom normally, but I realize that we really can do this at home. So I expect a lot of questions. You can ask them. They might not come up at the moment, but they will. Bloopers. Say goodbye to Harold. Say goodbye to Harold. My wife bought this and wants me to use it, so I don't know. Should I clean out my hair, scratch my back, point to Harold? I don't know. Have a great day, everybody. And don't be afraid to ask questions. I'm excited about your experiment too. I would be more excited if I was there to taste them. Man, oh man, I'm gonna have to do that experiment myself. All right, take care. Kennedy, good to see you.